So let's introduce a second-order differential equation. Right? So in the most general form, the left-hand side of a second-order differential equation is the second derivative of the unknown function, and the right-hand side is some expression that contains the independent variable, the unknown function, and its first derivative. So a linear second-order differential equation, meaning must be linear in the derivatives of the unknown function, right? So it is a linear expression in y prime, and y double prime. But it may be a nonlinear expression in terms of t, of the independent variable. Yeah, I'm sorry about the confusion. So here I denoted the right-hand side by g of t, and later somehow I switched to q of t. I hope it's not going to be too much of a trouble. Right, so if the right-hand side is 0, then the linear differential equation is called homogeneous. And if your equation is not homogeneous, so then you can just construct a very similar equation. So if you compare this equation and this equation, then the only difference is that you replace the right-hand side with 0, right? So if you replace the right-hand side with 0, then what you get is the so-called associated homogeneous equation of the original second-order linear differential equation. So a few examples. So harmonic oscillator, that's linear, homogeneous with constant coefficients. That's the law of universal gravitation. So here x is the unknown function. So let me maybe write that here x of t is the unknown function. Then the left-hand side is the second derivative of x with respect to t, and the right-hand side, in this case, it does not contain the first derivative of t, but still it is a second-order differential equation. So pendulum. So this is again a second-order differential equation. Here, theta of t is the unknown function, and g and l are parameters. So g is actually the acceleration of gravity. So on the Earth it is 9.8 meters per second square, and l is the length of the pendulum. So imagine that the pendulum could be something like 2.3 meters or something. But so the important part is that these are some specific constants. And again, it is nonlinear because we have sine of theta.